honest with you.
Good Thursday afternoon and welcome to Homework Helpers. Don't look at her. This is a show, as you know, because we have been doing this forever, which runs out in May, by the way.
May 28th.
Yes. But you can call with any question you like at 508-979-1600, and we will help you find answers to it.
Right now. We're here
right
live.
Right this second, from 5 to 5:30. When 5:30 comes, party's over. You can watch the show replayed at 7:30 tonight and 7:30 tomorrow morning, assuming everything goes well. But if you want to ask a question, you got to ask now. Call in. Cynthia Goodfellow will get your idea of your question and who you are and what grade level you're calling from. But you can be at any grade you like. And then we'll try to do what we can with the whatever question it is. My name is George Goodfellow, longtime science teacher. But sitting next to me is a longtime something else teacher. Hi, Masha.
Hello, Mr. Goodfellow. How are you, sir?
Mr. Goodfellow.
Lovely to be sharing the desk
formal.
with you. Marcia Guy here, a 4th grade teacher at the Ashley School in New Bedford. And waiting for your calls, anxiously waiting. Know you have homework because, you know, there's only one grade that ever tests in one building at one time.
Oh,
so
really?
all of your other grades could be calling in right now.
By the way, we want to thank the Bristol County.
The funding for our show. The Bristol County Savings Bank Community Charitable Foundation.
Yes, and also the New Bedford Educators Educational Foundation.
Right. So thank you very much for that funding, because without your support financially, we would not be able to be here sharing the stress of homework with the kids and lowering the stress for the kids.
And there are only 6 more programs, if I've done my calculations.
I'm actually not sure.
6 more programs, because we only air when there is school.
Right.
And of
course, on Tuesday, Wednesday, Thursdays.
Yeah, Tuesday, Wednesday, and Thursday. And school's coming to an end. Summer's coming. Last chance to get your brain fixed.
That's right.
So call in. Yes. So I have something interesting to show you, I hope. Also, on Tuesday, I thought we might do allergies. In case you're interested in allergies, tune in on Tuesday. And that includes Roland, my friend Roland, and my friend Jarrett, who always watches because they're very loyal fans.
And if I might add, my classroom, we have boxes. We have always had boxes of tissues all over my room. On every little bookcase where the kids put their book box for their personal reading pleasure, we have a tissue box on top of each one. Let me tell you, the tissues are flying, particularly this week in my classroom, from all those poor little boogies trying to get out from the allergies.
Did you call them boogies?
I did.
Oh my
well, you know how to make a tissue dance, right?
So
you put a little boogie in it.
Oh my God.
I'm sorry. Okay. Now
I'm so much more sophisticated than she is.
Oh, please.
I call them mung balls.
So now Tuesday, when we talk allergies, will you talk about how allergies affect some people in the nose, but me, it actually affects me in the throat the most?
Absolutely.
Okay.
And also why allergies you may not have now, but you may later. I didn't start allergies till I was like 45 years old.
Oh.
You'll see all that stuff. But today, we're going to answer a question from Mrs. Guy's 4th grade class later. But call in, because we'd rather listen to you and answer your questions than go rambling on about some scientific concept.
And we feel so much more helpful. We feel valuable when we can help you with your homework. Even if you got it done, remember this, even if you have it done and you just want to check to see, did I do it right? Call right in, 508-979-1600.
And it's more important after you've done it to call in.
Sure, to give it, you try first and then call in and say, hey, how'd I do?
And then I promise you, if you do your homework and then you call in just to check the question, you will remember that for a long time compared to just doing the homework. So call in.
Actually, that's probably true.
It is true.
Yeah, I'm thinking the same thing.
Educationally speaking.
Yeah. So,
and by the way, if you do have a question and you don't get to it between 5:30 and now and 5:30, We have an answering machine message at
Yes.
508-979-1760.
No, 1760.
1760.
Yeah, the answering machine, 508-979-1760.
And we also have an email at homeworkhelpers@newbedfordschools.org. I'm on the next 2 days.
Ooh.
So you could send me personally a question if you want, and I'll look at it and we'll get it ready for Tuesday. But right now, Mrs. Guy has a wonderful book.
Yes.
If she can reach you with it.
Oh, a good little connection, a little segue to the title of the book,
Segue.
which is When You Reach Me. Now, I remember Mrs. Darlene actually has loaned me this book. I'm going to let you know it's actually her book, alrighty? But she loaned this to me because she said, how could you not know this book? How could you not have already read it? Well, let me tell you. I took it home that night, and over 2 days on a weekend, I read this book. Oh, my goodness.
You know, speaking of reading the books, I don't know how many of the guys watching, the kids watching, know this, but when I read a book, I like to read until it gets interesting and then put it down and think about it for a while. And then go back to it, because you digest it more.
That's true.
Look, we got McKenna, grade 4, calling in.
Oh, there we go.
Some facts about the bird
called the
kingfisher.
kingfisher.
Ah, McKenna, are you there?
Yes.
Hello, dear. We love to hear from you.
Miss McKenna, how are you doing, sweet pea?
Good.
Now, Miss McKenna, before we get to your question, you'll forgive me. Has Mrs. Silvera heard that she won our award, the Homework Helpers Hero Award?
No, but I think she's going to hear it today because she watches it every night.
Excellent.
Yay.
Well, Miss McKenna, I'm going to be delivering the award to her before school starts tomorrow.
Perfect.
Tomorrow, I'm going to be bringing her, and she's got some pretty cool prizes too, which is a part of the award. All right.
And McKenna, you're the only one's going to know ahead of time.
That's right. So when you get to school, Miss McKenna, you make sure, Miss Silvera, did you get your prize? Okay. All right, baby. So what's your question?
So I just need a few facts on the kingfisher bird.
Yeah.
All righty.
Yeah.
Have you done any research on it yet, sweetie?
I got some facts out of the Social Studies Weekly.
Okay. Do you do the weekly reader in social studies, or is that a different thing?
It's actually called, let me check the front.
Sure.
It says Massachusetts Studies Weekly, People and Places.
All righty. Fair enough. It sounds like is it like 3, 4, 5 pages?
It's not the Scholastic News. It's the it's a different one. Like it looks like a big newspaper.
Sure.
But
very
it has
cool.
like facts in like all different places.
All right.
And McKenna, is a kingfisher that thing that looks a little bit like a woodpecker?
Yeah. It shows like a little picture of it.
Yeah.
And a few
That's so
facts.
cute.
It looks like a skinny woodpecker to me with a long.
Yeah, it
long
actually
face.
does.
But
Yeah.
it appears to me much smaller than a woodpecker.
Probably.
Well, it might look a little zoomed in to me because it's on a big piece of paper.
So what
Fair
have you
enough.
found out so far?
Well, I put a kingfisher is a type of bird.
Yep.
Their range are Europe, Northern Africa, Central and Southern Asia, and their habitat is near bodies of water.
Now,
So
do
we
they,
don't
do they
get any-
migrate?
We don't get any kingfishers?
Well, that's what I'm asking.
That's a little
Have
disappointing.
you found out whether or not they're a migratory bird?
I
think they are. I think they are.
Really?
But I don't know what their migration route is.
Yeah.
But Mrs. Guy is looking this stuff up right
I have.
right
I've
this
pulled it
second.
up, and I see on our map
Maybe we could put it on the
the
there you go.
distribution that we have here. And I'm not sure if I can zoom in.
Look
but
at the
I'm looking
TV,
over
McKenna.
here,
They're
sweet
gonna
pea.
be happy.
Northern Canada,
Northern
Greenland,
Canada.
the Sahara Desert, which is kind of odd. But then again, Northern and Central Asia.
We did a thing on migration one point. See if there's a migration path.
So I'm wondering, is there a migration path? I was actually looking at see, here's the beautiful bird.
Yeah.
Pardon me.
Yeah.
Here's the gorgeous bird. Come on.
With a
There we
long
go.
beak.
Yeah,
That looks
isn't that
exactly
pretty,
like the one
huh?
on my page.
Oh, where'd it go? There we go.
Look at it.
Isn't that gorgeous, huh,
Yep,
sweetheart?
that is an exact resemblance.
Yes.
And chances are it's a fisher. It eats fish.
Such vibrant colors. Oh, I can't imagine that
Yes.
tiny little snout
No.
gets fish.
It could pick up little fish out of the water, sort of like a crane.
Oh, the little ones, like the silver ones?
Like a crane does.
Okay.
But what else we got there? We got
Let me see.
migration. We got eating habits.
You're going to let me read here already. There are roughly 90 species of kingfisher, McKenna. All have large heads, long, sharp, pointed bills, short legs, and stubby tails. Sounds like my dog, Oscar. Most species have very bright plumage. That's the feathering. All right, honey? The plumage is feathering. With little differences between the sexes, which means the male species is not any brighter than the female species, which is rather an unusual thing, because in nature,
unusual.
the males are almost always brighter than the females. Come on.
What else we got?
They consume a wide range of prey, as well as fish, just like you said. You brilliant man, you.
Yeah.
Usually caught by swooping down from a perch. When wild kingfishers are usually thought to live near rivers and eat fish, most of the kingfisher species in the world live away from the water and eat small invertebrates.
Interesting.
Now, I'm thinking small invertebrate is worm. Yes?
Well, it could be, but it could also be aquatic species that are invertebrates.
Oh, but they don't live, they live away from the
but-
water and eat small
but-
invertebrates.
But the idea, a lot of times these birds go a long distance for their food and water because it protects their survival against predators.
Alrighty, sure.
know?
Don't, what is it, do your fighting outside in another place so that they don't know where your home is?
If you don't nest where you hunt,
Sure.
then you got a better chance of not being caught by predators.
All right,
All right,
Miss
what else we got?
McKenna. Actually, that's about it.
No migration?
It does not reference migration. I'm sorry.
And I also have one more question.
Yeah.
Sure, go ahead, sweetheart. Did we help you with that first? Was
We
that
were
good?
actually learning about fractals today,
Fractals, yes.
like nature fractals and geometry ones. So,
Sure.
if it's possible, can you teach me a little bit more about it? Because I'm not that straight on understanding it.
Well, here's the comfort I get, Sweet Pea. As a fourth grader, fractals not going to be a big part of your world. Alrighty? Not that you can't appreciate them, but to me, the fractals in nature are probably the most valuable thing for you right now. All right, honey?
Is that the way you're looking at it, McKenna? The fractals in nature?
Yeah, it's mostly
Yeah.
fractals in nature, and then we learned a little bit about it, like the geometry way, because our
Yeah.
teacher
Sure.
likes to get us ready for our next grade.
Oh, absolutely.
Oh, I see, yeah.
A little higher, too.
Yep. So, I'm not sure that I'm going to have an awful lot to be able to share from my own personal knowledge, sweetheart, because to me, fractals are to me, it's kind of a complicated thing. Although Mrs. Diggle
Yeah.
gave us a beautiful example of fractals.
The Fibonacci effect.
Yeah, the Fibonacci effect, and she actually made designs that she then broke out. And I'm so sorry, baby, that we don't have that example here.
But one thing I can tell you, McKenna, is a fractal is a sequence of numbers, and those numbers represent quantities, and you can find that kind of a sequence in naturally growing things. Everything from crystals to plants to land masses, and the sequence seems to occur in nature, which is kind of odd. So there's something going on in nature that is connected to the sequence that you find in a fractal.
So I'm going to actually click on something and on the computer, which you can see just by watching that. You can see the
Yeah, there are
repeated
a few of those
pattern.
in the computer lab today.
The repeated pattern, and you can blow it up and you can zoom in. And this is actually zooming out because it's starting very large on the blue and then zooming out and sucking, almost like sucking the blue into a vacuum cleaner from behind the screen.
It turns out, McKenna, in nature, scientifically speaking, if we're going to use this mathematical pattern, nature enjoys symmetry, if you know what that means. In other words, repeating
Oh, she
things.
absolutely knows symmetry.
Yeah.
Yeah.
In other words, things that repeat, chemical reactions, growing plants, even the way objects fall on each other. Symmetry seems to be favored. And a fractal represents the mathematics of that symmetry, if you know what I mean. By a sequence of number. Yeah.
I learned a little bit about that today in the computer lab.
Yeah.
Because our school pays for something called Study Island.
Oh, yeah.
And our teacher puts links on, and it had one I forgot what it was called. It was called something fractal.
Yep.
And you would make your own, with these buttons, and it would could
interesting.
create your own.
But I do want you to know that people have recognized this happens. But if I ask somebody, why does this happen?
Right.
There's not a good explanation.
Right.
It just we observe it in nature. We interpret it using mathematics. But to explain it, why this kind of a thing occurs, I'm not sure anybody's got a good explanation.
I do have, we're not putting on the screen, honey, the one fractal that Mrs. Diggle shared.
See, it's like a snowflake.
You start it as a triangle, and it expands, and
Yep,
expands
I see
again,
it.
expands again, expands again, and then all of a sudden you're thinking, That's no triangle. That's a snowflake.
Yeah, right.
Okay? And again, that's just one iteration. Once, twice, the third, the fourth, the fifth, sixth iteration
But notice
of that fractal.
But notice it keeps repeating. That's
Yes.
that mathematical sequence. Whatever is going on, how it splits or how it
Yes.
comes together, the pattern keeps repeating and repeating and repeating, which is a form of natural symmetry. So you should learn, I think, by looking at that mathematics, that nature favors symmetrical development.
And I want you to write another word down. All
Okay.
right, McKenna? Tessellation. Could you write that down on the overhead so that she has that?
I'm not sure I can.
Okay, you know what? I'm going to take the marker and write it down then.
Here you
I'm going to try to spell it out myself and
All
then
right.
see if I get the same as you.
Good for you.
I don't think I've ever heard that word.
A tessellation?
haven't.
No.
Yeah, we actually do it in art. Tessellation. And let's zoom in. And
Oh,
you,
so close.
and actually,
I
there
just
might be
needed the other
there might
F.
be another L in there, sweet pea. I did that on the run. Alrighty, but a tessellation is again a repeated geometric pattern.
Oh, I didn't know that.
But how they make it is that they make it so that it kind of tucks in, and it becomes a larger picture, and it's just really cool. We actually have some fun in workshop in June in my classroom with tessellations because
So
it's
McKenna, maybe you could look up tessellation on Google and see what you got.
yeah, and honestly, sweetheart, that to me that's the next step for you. You're looking at geometric figures now. Then you've already done symmetry. To me, the next thing is tessellation in the growing world, and then we'd go off to that gorgeous
Fibonacci thing?
Fibonacci fractal.
Okay.
All right, love.
All right, thank you.
All right, honey.
Thank you for calling, McKenna. That was great, as
You're welcome.
always.
As always,
Don't forget-
thank you for
don't
being
forget
such a
Mrs.
loyal listener, sweetheart.
Don't forget Mrs. Silvero tomorrow.
Okay, I bet she's very excited.
Yeah.
She should be.
Thank you.
All right,
Wonderful.
sweetheart. Thank you.
Leave it to McKenna to have a great question.
Absolutely. So, where'd my book go?
I put it over here
All righty.
because I knew you were doing fractally factual.
Yes. So I
And
wanted
I didn't
to.
want you to tessellate too much.
No, no.
No.
So this is titled "When You Reach Me."
Yeah.
Alrighty, and the author is Rebecca. I don't know if it's Stead or Steed. So whichever
probably.
one. Oh my gosh! So now here is the premise of this story. It is about a few kids in New York City public schools.
Yeah.
The setting, though, of the story is the 1970s when I was a little girl.
Oh, my God,
I actually
you are
like to say
old.
I actually like to say the olden days when I'm talking at school. But in 1970, I was 10 years old, and so this I can connect to. All of the things like being able to actually go home for lunch. We still did that in 1970. And
So you were born in 1960,
I was born in 1960. I
which
was
makes you 55 years old.
not yet because
All right.
my birthday's in July.
I just thought I'd tell everyone so they would know.
Oh yeah, you could all do the math. I have no problem.
Yeah.
I advertise that easily. I'm quite proud of actually surviving this long.
I was actually born in 1985. That's why I said.
In his
All right.
dreams.
All right, go ahead.
So anyway, it's about this group of friends in a classroom, and they're in and out of school, but it's also about time travel,
Oh, that's wild.
which I just didn't see. I didn't see it coming.
Where did it? Can you tell
really-
them? Can you tell them which way they travel in time?
I will not.
Okay.
And I won't tell you who, because I have to be honest with you, I didn't figure it out
Oh.
until they told me.
Oh, that's wonderful.
And that's how clever this book is. And
Oh,
I'm
that's
pretty
wonderful.
clever.
Yeah, yeah.
And I did not figure this out until they told me who was doing the time
So that
traveling
makes that
and
book
why.
really interesting.
And there are secret notes, which really get you hooked.
Oh, what a great
Yes,
book.
it is. Please read it. Absolutely, fourth graders could do this.
Can I open it up so they
Sure.
can see how big the printing is?
Fifth, sixth, seventh graders, easy peasy lemon squeezy. Really, it is just
Yeah.
a cool thing.
Yeah.
It really is.
And it goes 199 pages. Not bad.
You know, once you learn to
Not
love
bad.
to read, you don't even think about how many pages are in a book.
Maybe that's my problem.
Yeah.
All right. And it won an
It could
award,
be.
apparently.
Yes, it was that good, and that's actually how Mrs. Mrs. Christina Darlene hooked me up to this, because she's challenged herself. I guess a few years ago she challenged herself. She will read every Newbery Medal winner.
Oh, my goodness.
And God bless her, because I got to tell you, some of those Newbery Medal winners, they're remarkable stories, but they're so sad.
Yeah.
And I just don't like sad stories. You know, I like happy ending. Everybody's fine and safe and good, and nobody dies. Nobody
too.
gets, that kind of a thing. So, so that is my book being recommended for the day.
Excellent.
Alrighty.
And by the
Now-
way, we're down to about 9 minutes. McKenna
Yeah.
was nice enough to call 508-979-1600. If you call now, we'll have plenty of time to address your question with 9 minutes left. But if you wait much longer, we'll have trouble.
And just a shout out to Mrs. Silvera. I will be dropping by the school before school starts tomorrow to drop off your award and your prize. And we're just so thrilled that you support us as much as you do. Appreciate that.
And your check for $400 million. No?
No.
Oh, all right. Well, anyhow, while we're waiting for someone to call, I don't know if we can do this this time. I'll try to cut it short. But the question...
If not, it can carry over till Tuesday.
Oh, absolutely.
Alrighty.
The question from Mrs. Guy's class is, they were dealing with binoculars. So here's a picture of a binocular on the overhead. So they were dealing with binoculars, and the question came up, why is it that when I look like we're supposed to, the front way through the eyepiece, things get bigger, but if I look through the backside, the wrong way, what you see is smaller.
And remember that this thing allows you to scooch the binoculars so that the kids can actually look through both ends if they wanted to.
Yeah, depending on how far your eyes are apart.
Okay.
So it's a good question. I mean, it's a great question.
Yeah.
It's the kind of thing I thought of as a kid, too. But to answer that question, before we answer the question, I'd like to follow up what we had done last week so you can understand how light travels and you see.
Sure.
So if we look at the overhead again, at the
These are the convex and concave lenses, that kind of thing? Okay.
There are all kinds of lenses made out of glass that you can use. What I've got here, just so you can start learning a little bit of the wordage.
Sure.
This is a double convex lens. See? Double convex lens.
Oh, because there's the outside curve on both sides of the lens. Okay.
If it went the other way, just to show you, it would be a double concave lens. See this?
Where it's
concave.
It caves in in the middle on both sides.
Right.
Alrighty.
Now, all of these lenses, when they're made of glass or something that light can pass through, all of these lenses bend light. Just on one.
Alrighty, there we go.
Bend light a certain way. Now, it's called refraction, for those of you who like that word.
Right.
Refraction.
That's just the fact that the light bends.
Yes. When light changes...
When going through the glass, it's direction.
When light changes from one density medium that it's traveling through to a different density medium that it's traveling through, it'll bend one way or another. So let's pretend that's your eye. See your eye right over here?
Sure.
I drew that.
That's the pupil of the eye. And the eyelids or the eyelashes.
Eyelashes.
Got it. Okay, good.
So this pupil is talking to the pupils on TV. So anyhow, this is what I said the other day, and this is why I wanted to do it this way.
Yes.
Here's an object. It's in red.
And it's like a certain height.
Yeah. It goes from here to here. You cannot see that object unless light bounces off of it and goes to your eye.
Oh, yes, I remember the lights and the colors that were absorbed and not absorbed. I remember, yes.
So I wanted you to remember that because it helps you understand so much of this optics stuff. So light has to bounce off an object and go to your eye.
Okay.
So your eye's over here on the right, and here's the object on the left, the other side of the lens. Now, the way we decide where that light goes to when it goes through the lens is we take two beams from every point on the object. Now, I mean, it would take us all day to do every point on the object, so we're only going to do one point so you can see what goes on. We take two beams from every point on the object. The first beam is the one that goes straight into the lens.
Okay.
Whenever a beam of light goes straight into the lens, it bends and goes through what's called a focal point. That's why there's an F there.
Okay.
Every lens, depending on how much it's bent, has a different focal point. So somebody would tell you what the focal point was. But anyhow, the light that goes straight into the lens bends and goes through the focal point. In the meantime, the second beam of light that comes from that same point and goes through the middle of the lens, see the middle of the lens?
Yes.
Will keep going straight without bending.
Because there's no bend, there's no curve that it's having to go through?
There's actually two bends that are equal, so it comes up the same.
Okay, fair enough.
So now,
yes, I see that.
Yeah. So now, where these two beams intersect, that's right here, that's where you see the image of that point on the object. Understand?
Sure.
Now, in this case, when the object is between the focal length and beyond, where that light bends actually makes the image bigger. See this? This is much bigger
absolutely.
than that.
I see that now, sure.
You see that?
Yes.
So if I were looking at the object through this double convex lens,
Yes.
with the object in this position relative to the focal point,
Okay.
I would see that object in front of me
Larger.
upside down. See, it's upside down? The
Yes.
point's down here?
Yes.
And larger.
Okay.
Now, depending upon where you put the object, like look,
Wow.
here's an object inside the focal point. If you do the same thing here,
Yes.
a point of light comes here, bends to the focal point.
You're right.
The other point of light through the middle of the lens keeps going. And notice they don't intersect at all over
They
here.
don't.
So you say, oh my God, no image. No.
What's going to happen?
What happens is your eye interprets it as having intersected behind it, where it would intersect behind. Your eye sees light going straight, even though there is no light there.
How
This is-
does our eye know to do that?
Well,
Is it just like
well, if-
our eyes that smart?
well, you have to learn it as a baby.
Really?
If you were blind from birth and you were your age, and suddenly I gave you sight, you wouldn't be able to see originally. You have to learn to
Wow.
interpret light and turn it into images.
Isn't that something?
Yeah, it's really scary to
Yeah.
me. But, so in this case, with the object inside the focal point, there's the red object.
Yes.
The top of the object would appear to you to be behind and much higher, right side up. So now it got big. See how big it got?
Yes.
Now, if you do another situation, so you can see what happens when you look at the binoculars backwards.
Oh, this is the one we're looking the way you're not supposed to.
Right.
Okay.
Now the object is beyond the focal point.
Oh,
And that's
look at
pretty much
that.
what you do with binoculars.
Yes.
You look at it at an object far away.
Yes.
So
Because
here's
you
that,
want to see it close up.
here's that object, and if I take the beam that goes straight into the lens, it bends through the focal point.
Sure.
And the beam that goes through the center lens keeps going. It intersects down here. Look.
Isn't
the object
that
goes
something?
upside down, and it's tinier, smaller. So
That's just amazing.
it is amazing. So
That is
depending
just
upon which
amazing.
way you're looking at it, the light is bent differently, and your brain interprets the image. So now here's the binoculars again.
Oop, let's zoom out.
Yeah.
Oh, no, we're good.
Oh, that's good, yeah. The way binoculars are designed, that's why I didn't want to get into all of that detail.
Right.
Is there is a lens over here. It's actually called a single convex lens.
Okay.
So-
So it's flat on one side.
Flat on this
and
side.
rounded out,
Out
on
over
the
here.
other.
So the
Alrighty.
light comes through here, it bends, but then they pass it through some prisms, so it goes around a corner and goes through another lens.
Right.
And then a third lens.
Aha.
The overall result, they've made this, is so the object becomes larger when you're looking the right way
And right side up.
and right side up. So now, if you looked at it the other way, it's the same set of lenses, but
Sure.
now the light is coming in this way
Yes.
and coming out that way, and so it becomes smaller
Completely smaller.
because it does the opposite of going through the lens the other way.
Alrighty.
So now, looking through a binocular the wrong way, we call it the wrong way. but
Yes,
I
yeah.
used to always like to look at it that way.
Yeah, not the way that it's meant.
No,
Sure.
the object becomes smaller.
Alrighty.
Okay?
Yes.
This is a very important topic in physics. It's called optics, and it gets very complicated. And the things that people do with optics, what you're watching us on now is a very sophisticated, amazing set of optics that's going through this camera I'm looking at right now. And then the light is moved to wherever they want to move it, and they expand it, and they make it bigger, small. I mean, it's just, those people are the people in our control room are brilliant. Brilliant people.
And we think even a little magical. But
They are
I
magical.
hate to say this to you. We need
Oh,
to say goodnight.
no.
Yes.
McKenna, thank you so much for calling.
508-979-1760. If you have a call and you weren't brave enough to call live, it's okay. Homework helpers at newbedfordschools.org.
Perfect.
We wish you well. Have a great weekend.
And we'll see
we
you
hope that-
Tuesday.
And call in Tuesday.
And don't forget 7:30 tonight and 7:30
Tomorrow morning. And I'll see you in the morning, Mrs. Silvera.
Thanks for the questions.
And
Bye.
you guys are great kids. Do your homework and call us because we're here to help. We love you.
Cheers. You haven't been